Hello guys, this is Rishikesh. In the previous videos, we saw the basics of center of mass, and then we also saw how can we find the position of center of mass of system of particles, and then we did few problems on the center of mass on calculating the position of center of mass, and then we also saw like how can we calculate the center of mass of a continuous bodies, which is in a way different from calculating center of mass of a system of particles, because for the continuous bodies we use integration, and then we found out center of mass for few of the symmetrical bodies, and today we will look into motion of center of mass. It's very important concept, because with this we'll be able to solve a lot of problems, and actually this is a basic of application of center of mass. So let's start with motion of center of mass. So recall that in previous video we found out center of mass of continuous bodies using this formula. So this is the general formula for system of bodies. Recall that in previous video we saw that the center of mass of number of particles, system of particles, can be calculated by this formula. So here x gives the center of mass, x coordinate of center of mass of system of particles. So it is given by sigma mi xi by m. This the denominator is this m is the total mass of all the particles, and this y gives the sigma mi yi by capital M, and similarly for z. Recall that in previous video we saw that we can calculate the x coordinate, y coordinate or z coordinate of center of mass of system of particles by this formula respectively. तो हमने पढ़ा कि हम जो सिस्टम ऑफ पार्टिकल्स के लिए जो हम सेंटर ऑफ मास निकालते हैं, उसके लिए हमने ये इक्वेशन लिखा, जनरल इक्वेशन लिखा, जिसमें ये जो m है, दिस m इज द मास ऑफ ith particle इन द सिस्टम, और ये xi जो है, xi is the x coordinate of that system of particle, that ith particle. Similarly for y or z, if we combine these three equations into one equation and represent it into the form of position vectors, then let's see how we can. Let's assume that ri जो है small ri is the position vector of ith particle. ठीक है, यहाँ पे we are talking about x coordinate of ith particle, यहाँ पे we are talking about y coordinate of ith particle, but here we will represent this into the form of position vector. So let Ri be the position vector of ith particle, then we can write it as I cap, j cap and k cap is these are unit vectors along x, y and z direction respectively, and let us represent position vector of center of mass, which is here we are representing x coordinate of center of mass, here we are representing y coordinate of center of mass, here we will represent all this into one, which is the position vector. So basically we are writing it into the form of capital X I cap plus capital Y j cap k cap, right? So we can write this as, then with this formula these three will get combined into one, and this will look like mi ri by m, right? So this is basically a representation of uh, all these three equations into the form of position vector. So we can replace these three into one, and then uh, this is capital M. So let us take this M to this side. Now we're talking about we are doing this all this to just to explain you the motion of center of mass. So let me quickly add the topic here, so that if you're wondering why I'm doing this all these things, then with this topic we will have at least some perspective. And now like that MIRI. So this one we can also write as MR equal to M1 R1 plus M2 R2 plus so on, right? M2 R2 plus so on. So if we differentiate this with respect to time on both sides, then this will become M dr by dt, and this will become M1 dr1 by dt plus M2 dr2 by dt, so on. So we know that dx by dt, in this case dr by dt, is equal to velocity, right? M. So this dr by dt will become capital V, because here capital R represents position vector of center of mass. So here capital V will represent velocity of center of mass, and then this one will become M1 V1 small v1 plus M2 small v2 plus so on, right? So if we differentiate this one again with respect to time, this will become M dv com by dt plus M1 d small v1 by dt plus M2 into small dv2 by dt. So this one we can also write it as M into capital A. This is the center of mass, acceleration of center of mass. Then this side will become M1 A1 plus M2 A2 plus so on. So these are the acceleration of the this A1 is acceleration of uh, M1, this A2 is acceleration of M2. So these are the different M1 M2 are the particles in the system. So we know that from the Newton's second law that force applied on any body is equal to mass of that body into acceleration due to that force. So we can replace the RHS this side by the force individual forces on the ith particle. So we can say this one will become F1, this one will become F2, and so on. Keep in mind that these forces are not individual forces on each particle. This is the force uh, which is the resultant of all the forces. तो ये जो फोर्स है वो सारे फोर्स का रिजल्टेंट है जो उस पार्टिकल पे लग रहा है, ठीक है ना? तो ये जो एक्सटर्नल, दिस फोर्स कैन बी बोथ एक्सटर्नल एंड इंटरनल फोर्सेस, ठीक है? बट वी नो दैट this one could be both external and internal. We know that कि internal forces जो है कैंसिल करते हैं एक दूसरे को, इंटरनल फोर्सेस कैंसल्स ईच अदर बिकॉज दे एक्ट इन एक्शन रिएक्शन पेयर, है ना। तो वी कैन ignore these internal forces, and then actually we can write it as ma form is equal to F, which is only the external force, because we know that the internal forces cancels each other, so इसको हम इस फॉर्म में लिख सकते हैं, है ना। ये बहुत ये बहुत इम्पोर्टेंट फॉर्मूला है, ये बहुत इम्पोर्टेंट इक्वेशन है। इस इक्वेशन से हम दो तीन इम्पोर्टेंट पॉइंट्स हम लोग समझ सकते हैं, जान सकते हैं, और हमको याद रखना चाहिए, which will help us in solving the problem. The first one, so center of mass of the system particles move as if all the mass of the system was concentrated at the center of mass, which is given by capital M, and all the external forces were applied at that point, which is this F external. The second point is, we can say that if this if F external, if there is no net, if there is no net third point that we have already discussed is motion of center of mass of a system or object is not affected by any of the internal forces. Motion of center of mass is not affected by internal forces. We have already seen that there is no F internal here, right? So, and what kind of internal forces we are talking about? For example, if two bodies move towards each other due to internal force, due to mutual attraction or electrostatic attraction, due to gravitational force between them, or electrostatic forces third is motion of center of mass is not affected by any of internal forces, right? Because they cancels each other, right? So suppose, example, if two bodies are due to the gravitational forces or electrostatic force, right? So now we'll do some problems.